Hi guys. I have your paper plate activity printed out, and really disappointed that I can't do this with you, that I have to do it for you. But we'll do it together as best as we can. So we are getting ready to start a unit on trigonometry. So basically, second semester of high school pre-calculus is what colleges call one course of trigonometry. And to get started with trigonometry, I need to introduce a different unit of measuring angles, and that is a radian. So just as you are somewhat familiar with, you can measure in feet, you can measure in miles. Of course, there are all kinds of other units of measurement for length, but 1 mile is equivalent to 5,280 feet. So we're going to kind of look at the correlation between degrees and radians. We're going to start measuring angles in radian units. And so I kind of want to show you where radians come from, as well as how they correlate to degrees. It's kind of cool. So I'm just going to take this paper plate activity and just going to walk through each step. The first step, it says to flatten my plate. So I'm going to try to flatten the plate out. And step 2 says fold it in half and fold it in half again and quarter it. So I've done that. I've already flattened it and quartered it. And let's see. Well, I don't think it says to do this, but I'm going to, yeah, it does say trace 2 diameters. So I'm going to fold my plate taco style, grab my marker, and I'm going to trace each diameter on both sides of my plate. And to save time, I've already done that. So I have quartered my plate on both sides. Okay. Step 3, on one side, label the angles in degrees. All right, y'all know these. We start out with 0 degrees. And then up here is going to be 90 degrees. 180 degrees. 90 more makes 270 degrees. And 90 more makes 1 complete revolution, which you very well know is 360 degrees. Okay? And then the string that I would have provided for you, already cut. How long is the string? Well, if you take the string and lay it across your crease in your plate, it's the length of 1 diameter. How long is the string? It is 1 diameter in length. Alrighty, moving on. On the other side of the plate, already did that. Step 6, mark the string at 1 radius. So the length of my string is 1 diameter. I'm going to fold my diameter in half, and you all know that half of the diameter length is a radius. So I'm going to mark on my string the halfway point. And you can see that half my string is, yep, it is the length of 1 radius of my circle. Okay, here's where it starts to get cool. Starting at 0, wrap the radius around your plate. So, 0, start wrapping the radius. And once I get to 1 radius, I'm going to make a mark on my plate. 1 radius length took me from here to here. And I marked it on my plate. Okay, I'm going to keep going. That's 1 radius length. I'm going to do another one. And I'm going to mark it. That's 2 radius lengths. Okay, let's do another one. Do you think I'm going to make it to 180? Let's see. 3. So close. So close. 3 radius lengths just got me barely short of 180 degrees. So this is 1r radius, 2r for radius, 3r for radius, and I need just a smidge more to get to 180 degrees. I wonder how much more I would need to get to 180 degrees, to get halfway around my circle. Some of you are putting the pieces together in your mind right now. I need a little more than 3, and it has to do with a circle. You know what? I'm thinking 1 radius, 2 radii, 3 radii. I'm thinking I would need 3.14-ish. Or how about this? Maybe I need 3.141592.6 blah, 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 to get halfway around my circle. Sure enough, it's pi. I need pi of these. Of these to get halfway around my circle. All right, let's keep going. That was 3. So I'm going to pick up where I left off. I'm not going to pick up at 180. I'm going to pick up at the 3. So 3, keep it going around. That makes 4. 1 more makes 5. And 1 more makes 6. Do you think I'm going to make it? No, I'm not going to make it. I'm going to come up short. Four radius lengths, 5 radius lengths, 6 radius lengths, and I came up short. How much short? That much again. So I think to get all the way back to do 1 complete revolution, I think I would need 6.28. It took me 3.14 to get here, and I was 0.14 short. I'm going to be 0.14 short on top of that, so I'm going to be 0.28 short. So, back to the activity. How many radii did it take to complete 1 revolution all the way around? 6.28-ish, or I can just call it 2 with my pi symbol, 2 pi. 2 pi is how many times my radius wrapped around my circle. And here's what's cool. I know we're getting ready to talk degrees, but do you remember the formula for circumference of a circle? The formula for circumference of a circle is capital C equals 2 times pi times r. 2 pi r for the circumference. You know why? Take the length of a radius and times it that many times. That's what we just did. The length of the radius, 2 pi times, or 6.28-ish. That is cool. All right, now let's kind of try to correlate this. Let's go to the back, and I hope you can see what I'm writing. Maybe I can make it a little bit bigger. All right, on the back, let's start with something easy that you already know. 1 complete revolution in degrees, you all know, is 360. And half of that, a half of a revolution, would be 180. A quarter of a revolution is half of that, which is 90. Okay? Now, let's look at the correlation between degrees. Clean radians is where we're going to use the pi symbol. Yeah, what I call yucky radians is where we're going to use rounded decimals. So, do you remember how much 1 revolution was in terms of radians? It was 2 pi. Or, with a rounded decimal, it was approximately 6.28 radians. All the way around. that in half. How much is half of a revolution? Cut 2 pi in half. What do you get? You just get pi. What's that correlated in rounded decimal? That's approximately 3.14. So where am I? From start, halfway around is 1 pi, or approximately 3.14 radians. Okay, let's do a quarter of a revolution. So if from here to here is 1 pi, cut that in half. You get 1/2 times pi. Now here's how we're going to write it. 1/2 times pi. We're going to write it as pi over 2. We're going to write this so many times that it's going to get too cumbersome to write 1/2 pi every single time. We're just going to write it as pi over 2. Well, what's the decimal equivalent of pi over 2? I don't know. Let me find out. So I'm going to grab my calculator and I'm going to say, what is pi divided by 2? So 3.14 divided by 2 is approximately 1.57-ish. 1.57-ish. So all the way around in clean radians using the pi symbol, all the way around with my rounded version. Halfway around, 1/4 of the way around. Okay, I'm going to go to my circle and I'm going to label that. So I've got 0 radians. 1 revolution was pi. Half of that was pi over 2. Okay, what's this one down here? Okay, this is where fractions start to become really important. Ready? I'm going to start counting. This is 1 pi over 2, 2 pi over 2, which reduces to pi, 1 pi over 2, 2 pi over 2, 3 pi over 2, 3 pi over 2. Remember, I was just counting. 1 pi over 2, 2 pi over 2, reduces. 3 pi over 2, 4 pi over 2, reduces to 2 pi. 1 pi over 2, 2 pi over 2 reduces, 3 pi over 2 doesn't reduce, 4 pi over 2 reduces. All right, got my plate labeled on both sides, one side in degrees, one side in radians. Now, let's look at just a single quadrant. So if I just look at the first quadrant, in degrees, you all know that quadrant 1, 90 degrees. If we take quadrant 1 and we cut it in half, so take 90 degrees and cut it in half, we get 45 degrees. Or if we take quadrant 1, 90 degrees, cut it into thirds. Thirds would be 3 angles of 30 degrees each. Let's do that with radians. So remember we said that 90 degrees in radians was pi over 2. And that was approximately 1.57 radians. All right, ready? Let's cut that in half. Pi over 2. I'm going to take pi over 2 and I'm going to cut it in half, which means I'm going to multiply by half. And I get 1/4 pi. But I'm going to write it as pi over 4. And then in decimal, take that, cut that in half. In decimal, that's approximately 0.79. Approximately 0.79. And then kind of start over. I'm going to take pi over 2, I'm going to cut it into thirds. Pi over 2 times 1/3 gets me 1/6 pi, or I'm just going to call it pi over 6. Pi over 6, and pi divided by 6 is approximately 0.52 radians, 0.52 radians. So you can see, remember in our circle, when I marked 1 radius length, that's 1 radian measure. So if I make this angle right here, that angle right there looks to you as about probably 60-ish degrees. But in radian measure, it's 1 radian. That big angle is only 1 radian. From here to here is 1 radian. From here to here is 2 radians. From here to here is 3 radians, and halfway around is 3.14 radians. Okay? And then from the starting place to here would be 4 radians, 5 radians, 6 radians, and you know that that doesn't quite get us all the way around, because all the way around is 6.28-ish radians. Okay, so this big angle right here is 1 radian. Sometimes we will look at radian measures in complete numerical form. So like right here, this is just a flat out number. Sometimes we will look at radian measure like this. And when we look at these, like when we look at a radian measure of 0.79, you think, gosh, that's small. Well, yeah, but it's still a 45-degree angle. So this is a thing, but it's not frequent. These are going to be frequent. Holy moly, we're going to use the same thing. It's the same thing, but it's with a pi in it. It's with a pi symbol in it. This is what we're going to use most of the time, but sometimes we'll have to do a little bit of work with decimals. Okay, so there's a good correlation. Get you started between degrees and radians. Also, fun fact, 1 radian, remember we thought it looked about like 60 degrees? Turns out 1 radian is approximately, rounded, 57 degrees. 1 radian is approximately 57 degrees. Okay, now, to get you going, I need you to start becoming familiar with radian and degree measures. So, need you to do 2 things after this video, or during this video, whatever. One thing I need you to do is take out your reference sheet. Your reference sheet's a 2-sided paper. It says one side it's going to be in degrees, the other side it's going to be in radians. So the first thing I need you to do is go around and fill out this circle with degree measurements. So of course, you've got this. 0, 90, 180, 270, 360. These angles, to get the middle one, you're going to cut quadrant 1 in half. Okay, so cut quadrant 1 in half, 90 cut in half, this is going to be 45. So you need to be labeling this. So from here to the middle is 45. 45 more makes 90. Keep it going. Ready? 90 plus 45 more gets you to the middle. 90 plus 45, write it down, whatever you get. and 45 more should get you 180. The camera. 90, or sorry, 0, 45, 90, 45 more, 180. Keep it going to the middle. 45 more, label it. 45 more. Oh, it should already be labeled. 45 more gets you to the middle. 45 more gets you back here. Okay, that's easy. Now, let's do the other two. So, forget about the middle line right here. Let's just look at from here to here. Forget this. Same, same. You can see that these came from cutting my quadrant 1 into thirds. 90 cut into thirds. This is a 30-degree angle. So 30 degrees. Label it. Skip this one. 30 more makes, label it. 30 more makes, it's already labeled. 30 more makes, label it. Skip. 30 more makes, label it. 30 more makes, oh, you've already got that labeled. 30 more, 30, okay, keep it going all the way around. Then you're going to flip the paper over, and you're going to label in radians. Now, this one, I'm going to do some of this in pencil because some of these are going to be reducible. So radians, let's start with what we know. We know that starting out is 0, halfway around is pi, all the way around is 2 pi. Halfway around is pi. Cut that in half, and we get pi over 2. Or you can think of it as 1 pi over 2. Let's label this one down here, and I'm going to use my fraction skills, and I'm going to count. Ready? 0. 1 pi over 2. 1 pi over 2. 2 pi over 2. Oh my gosh, that reduces. 3 pi over 2. That doesn't reduce. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Oh, that reduces. So, of course, I'm going to use the reduced version, pi and 2 pi. Okay? Just trying to get you comfortable with some fractions. Now, let's cut this quadrant in half. Pi over 2. Cut it in half, we get pi over 4. And I'm going to let you do the rest, right? So from here to halfway, so we're ignoring the other two. We're just looking at the halfways. Ready? From here to here, 1 pi over 4. 1 pi over 4, 2 pi over 4. 2 pi over 4. Well, look at that. That reduces. We already have it. 1 pi over 4. 2 pi over 4. 3 pi over 4. Write it down. 4 pi over 4. Oh my gosh, that reduces. I've already got it there. 5 pi over 4. 6 pi over 4. 6 pi over 4. It's already there. It's reduced. 7 pi over 4. 8 pi over 4. And 8 pi over 4 reduces. Okay? And lastly, let's do the small ones. Where do these small ones come from? Well, I'm going to take pi over 2 and I'm going to cut it into thirds. We've already done this on that sheet of paper. Pi over 2 cut into thirds is pi over 6. Pi over 6. Now, I'm going to ignore this because I'm looking at 30-degree increments. Pi over 6 increments, 30-degree increments. So here, and then here, and then here. I totally bypassed the middle one. See that? Here I go. I'm going to start counting. Here's where fractions come in. Knowledge of fractions come in handy. 1 pi over 6. 2 pi over 6. 2 pi over 6. I wrote that in pencil. You know why? It reduces. 1 pi over 6. 2 pi over 6. Reduce it. 3 pi over 6. Oh, it's already there. 4 pi over 6. Reduce it. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. 12 pi over 6. So I want you to fill all those in. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Fill all those in, of course, reducing every fraction that you possibly can. This is going to become your reference sheet. You're going to have it out like pretty much every time you do your homework for quite a while until you pretty much have them all memorized or are really quick with coming up where they are. And so this is what you need to fill out, as well as you have a Google form to get you familiar with where those angles are. All right. Thanks, guys. Good luck.